Want to kick us off, Brian?
Yeah, well, I guess, hello, everyone. How are you?
We're fine.
Got about 8 people on the line here. Sam and I are in his studio at his office. And so we're going to try to work this. To be very honest, absolutely nothing is rehearsed. Hey, what we thought might do, I think we've only got about probably less than 10 people, is maybe have each person just take, 30 seconds to say your name an organization or something. If you want to say one other thing, that's fine. You want to do that?
Hi, yeah. Bruce Judd, Strategic Decisions Group. Good to see you, Sam.
Good
and always to see you, Brian.
Jim Holtman. I'm with Kroger, the grocery store company. I work in their operations research group.
Oh, great.
Jim, hi. Well, he was at our meeting a couple of years ago.
Yes, correct.
Oh, okay.
Yep, been to a couple of your workshops.
Good.
And Mike Jerbick?
Mike Jerbick, formerly with San Jose State, and now cyber risk analyst for my main profession.
Patrick, hello.
Yeah, Patrick Whittington. I'm just here because I'm interested. I took a couple classes on Stanford Online in the Decision Making with Insight book, went through that. Just interested in the general decision-making process. I'm a commercial airline pilot on the side. And
Wow.
Okay.
No kidding.
glad to be here.
Yeah.
Fantastic. So,
Yeah.
so I used to fly gliders, right?
I did not know that.
Yeah. Putting an engine on an airplane is a moral hazard that tempts the pilot beyond gliding distance of the field.
True. However, when you have an ejection seat, that helps everything also.
Hi, I'm a global IT manager for International Paper in Memphis, Tennessee.
Memphis, Tennessee.
Wow.
All right.
Great.
All right.
And Tom Chestnut.
Speaking from beautiful downtown Encinitas, I am with A&N Technical Services, and I do water analytics.
Oh, Laura Keating. We didn't call on you.
Hi, can you hear me?
Yes.
Super. I'm phoning in from Calgary, Canada. I work at the Calgary Zoo as a conservation research data analyst. I used to work in decision analysis at Strategic Decisions Group. And before that, I worked as a wildlife biologist.
Well, I'll tell you what, we're going to get started. And
So I want to welcome everyone to the Greater Bay Area chapter meeting, where we have people from East Coast, we have people from Calgary, and we may have some people from elsewhere. So San Francisco has really gotten greater right on this meeting here, okay? So we have a bunch of sponsors that support SDP of CDA, Chevron, Decision Frameworks, Chromite, KCA, SDG, Shell, SmartOrg, and Texas Executive Education. And without these people, it would be difficult for SDP to do what they do. So SDP has got kind of 3 objectives here. One is to promote decision analysis and decision quality, to make good decisions. We want to create value with the right tools, which is oftentimes difficult. People tend to use the same hammer or the sledgehammer for everything, and they really need to adjust that. And then we want to advance the profession. I think one of the things that bothers me is that, we've been doing this since, I think, the 70s, and Tom Chestnut may be able to, probably knows all about that. But anyway, it hasn't gotten the penetration that I think it should have had, given how many years we've been working on this. So that's one of the objectives of SDP. I do want to remind people about the DAG conference in 2020. It's in Houston, March 31st to April 3rd. We have a couple of keynote speakers here. One is Ed Rogers, who's the Chief Knowledge Officer at NASA. He should be interesting. And Martin Hilbert, and he's going to talk about analytics dooms us to repeat the past. What do you do about it? And when I read that, I think about the big data and data science and using all the historical data. So anyway, those should be interesting discussions. There are some workshops that occur on Tuesday and Wednesday prior to the conference on Thursday and Friday. We got a lot of great signups, and you can see that the one by Ralph Keeney is almost full. In fact, it might be full now. This was done some time ago, I think. Well, maybe not. And then as part of the being a member of SDP, well, actually, you don't even have to be a member of SDP. SDP offers monthly webinars almost every month about different subjects. So you can see you have one here on February 19th, cognitive, motivational, and group biases, and then another one on the 26th about visualization. So these are all good things, and you can join SDP by going to decisionprofessionals.com and clicking on the join. And so the benefits that I've already mentioned, the monthly webinars. They also, as a member, you then have access to all the historical webinars. If you're not a member, you don't have access to those webinars. And also, as a member, you have a discount to the DAG conference. There's also recognition with your peers as being a member of SDP. And SDP does have a certification process where you can, there's 3 different levels, and you can apply to be certified. And I'm actually on a certification committee right now, and we're working to advertise that a little bit more within SDP. So being in the SDP San Francisco chapter, I'm not sure how this is going to work on saying networking with Calgary and Florida or whatever, but anyway, we have communication among professionals having interest in decision analysis, and we get to share a bunch of information. I think Sam's going to show us something that's very different from what you're probably used to doing. And so the cost of membership is $250 as a regular member. And then if you're a student, I'm not sure we have any students, but they are free. So if you're associated with some university or something, you might encourage your students to join us, because it doesn't cost anything, and there's a lot of benefits and a lot of networking that goes on or can take place within SDP. So Sam's going to give us a demonstration, and hopefully we're going to have a good dialogue here around networking, stochastic libraries. So he is the Executive Director of Probability Management. He's the author of Law of Averages, which is a great book if you haven't looked at it. It doesn't have a lot of equations in it. The only equation he's got in there, he poo-poos a bit. He's an adjunct professor at Stanford. He's a fellow at the Cambridge University Business School, and he's inventor of the SIPs, Stochastic Information Packets. There's also something he'll bring up probably as a slurp. So I'll let him define how the SIPs and the slurps relate. So I think with that, I'm going to turn it over to you, Sam.
Great, thanks, Brian. So I don't know how many of you are familiar with probabilitymanagement.org. Let me bring that up on my probabilitymanagement.org. Is a 501c3 nonprofit that we are trying to do for uncertainty what Arabic numerals did for numbers. Now, in this age of bombast, I don't want to be left behind, but I have a new approach. I call it evidence-based bombast. And so you'll notice we've had support from a whole bunch of companies, and a co-founding board member was Harry Markowitz, Nobel laureate. And I'm about to show you what I mean by the Arabic numerals of uncertainty. And in fact, this also serves as a whiteboard when I need it. So let me just, first of all, start out with what I call the arithmetic of uncertainty. But let me define for you the arithmetic of uncertainty. So in arithmetic can tell you that x plus y equals z. The arithmetic of uncertainty says, what do you want z to be? Here are the chances. And let me give you an example of what this looks like. You would be amazed that basically right now, you can engage in the arithmetic of uncertainty. So imagine there is a farmer somewhere. The farmer, the only thing they're sure of is they have 5 acres of soybeans. This is the distribution of yield per acre. The farmer doesn't know it, so that distribution is in the cloud. And by the way we think of uncertainty is like 10,000 parallel universes. I love to use the metaphor of Rick and Morty, which no one had heard of before the Super Bowl. Now that there was a Rick and Morty cartoon in the Super Bowl, I don't feel so embarrassed talking about Rick and Morty, but Rick and Morty is a cartoon about a drunken mad scientist grandfather who goes flying around through the multiverse with his grandson in their flying saucer full of empty beer bottles. Or anyway, so right now, that uncertain yield is actually hooked to 10,000 trials in the cloud. So if I look at trial 1, 2, 3, 4, oh, there it is. I'm not expecting the farmer to know the distribution, but I want them to have a trusted source. Here's the price of beans in September, or the price of beans in November. I do want the farmer to know how to do this, and they do know how to do this in Excel. Revenue equals the number of acres times the bushels per acre times the price. Bam. So that was 10,000 trials before your finger left the enter key in native Excel. I could sell this file to 1.2 billion people. Now, I'm only going to send it to you folks, but it would all go out there, hooked to the cloud, and there is one new thing I want the farmer to learn how to use. So the farmer doesn't know they have a logarithmic utility function. They don't want to hear the word utility function. What they want to know is, what's the chance that this is greater than 10,000 bucks so I can buy a new tractor? Well, we can do that. Up here is the chance of whatever button. There's some other tools on here as well, because it's 2020. By 2021, I want all of them to go away, and there will just be a chance of whatever button that works like this. So the chance that this output bears this relationship to that target value is 25%. I mean, I can do these things in my head, but a lot of people would need a simulation to do it.
So now if you change this from November to September or August, we'd get a different
Let's try that. Let's try that. So let's go to September beans. Oh, still 25%, but the distribution changed. August beans. Let's look at something else here. How about I lose the farm if it's less than 7,500? That's 14%. Let's see if that varies by month. Yeah, it's down to 12% in September.
There's not no variation here in the prices, though, I think.
No, not too much. Now, what's going on, if you haven't seen this before, is that we are exploiting the data table function in Excel, which is kicking out the revenue, 10,000 revenues per keystroke. Now, doing interactive simulation, by the way, allows you to use a different part of your brain in this whole procedure. So we're not looking at equations, and I don't use a lot of equations. I refer to this as limbic analytics because it connects the reptilian brain to the rest of your brain. Now let me describe the concept of SIP libraries, because you can't, this is what networks simulations together. One simulation writes out a set of Monte Carlo trials called a SIP. That's one column. But any other simulation in the world can then read that in. And that's the way we network simulations together. So I'll give you a, we'll take a look at a SIP here, first of all. And
so right now there's a SIP for each one of those months, conceptually.
That's right. Oh, and those were generated at a very interesting place called FarmDoc. FarmDoc has got this incredible kind of Black-Scholes pricing gizmo to create the distributions of future prices of soybeans and corn. I'm just going to say that we have a project that has 10 parallel tasks. Each one takes on average 6 weeks. And we're uncertain about the task, so that could happen, or that could happen, or that could happen, or that could happen. Now, what I'm doing here is I'm actually scrolling through a library of 1,000 trials in this case. So if you've done these tasks before, you've kept track of how long they would take. This is make-believe, those are triangles, but it could be whatever distribution it was. Then it means that when we look at the time to complete, it's really an index statement into that library. Let's scroll down here. We can then do, oh, I think it's important just to remind everybody, you know, what's the chance of finishing in 6 weeks? It's 1 in 1,000, because you can think of each task as maybe having a 50-50 chance of being over or under 6 weeks. And the only way you're done in 6 weeks is if all 10 of them are less than 6 weeks. And so that's like flipping 10 heads in a row. So it's 1 in 1,000. That is a classic example of the flaw of averages. Most of you have heard of the statistician who drowns in the river that's on average 3 feet deep. It says that plans based on average assumptions are wrong on average. And then, of course, the other famous example is the drunk wandering down the middle of a busy highway. His average position is the center line, and at his average position, he's alive, but on average, he's dead. So these are errors that are not even close enough for government work. It's called Jensen's inequality by mathematicians, but I call it the flaw of averages. Now, I want to show you how one program can create a SIP library for use by another. So here I have a forecast. Very simple regression. So I had sales. This is from, obviously, the last time I showed this was 2017. I have sales and years, and I run a simple regression. It's live. It's in Excel. And I end up with a slope and an intercept. And one of my Stanford students last week was saying, my gosh, negative 4 million for, how the heck could you have sales of that? I said, well, those were the sales at the birth of Christ. You know, when you have these regressions and you run, now there's kind of a limited range, but here's the standard error. And that means that in SIP math, we can instantly simulate the demand as the intercept plus a slope times a year plus the standard error times a normal 0, 1. And that then will appear on this output sheet, which we can save as a library. Now, just going back to the forecast for a second, notice that if I put in this second library, the second data set, right? Boom, much smaller standard error. The standard error is now that number as opposed to here. Undo, and it's that number. Most of you probably have never heard of unsimulating, right? No, it's, you know, Control Y plus 1,000, Control Z minus 1,000. It's just really like a deterministic model with 1,000 parallel universes.
But Sam, I think there's a really important point here that when you do these simulations, do an undo and do again, you're getting the exact same number.
Yeah, so very important that if you're doing calculations with SIPs, SIPs are auditable data. And here, step into the screen for a second, because I just want to know,
yeah,
have you ever heard the words simulation and accountant in the same sentence? No, because the accountant would go nuts. Right. And so
I've heard management say, why is the answer different? He says, well, I ran a different Monte Carlo.
Right.
That's what I hear.
That's terrible.
Yeah,
so here's the deal.
Yeah.
When the accountants come calling, you say, oh, no, this is a deterministic model. It's based on 50 million numbers. Why don't you audit those for us and come back when you're done? So I'm going to show you now, I'm going to use the library that was created by the forecast program in another program. The below projection model. The flaw of averages really explains why everything is behind schedule, beyond budget, and below projection. So here's the below projection version. And it's basically the capital investment problem with uncertain demand. I like to think of it as we're buying something for the Christmas season. It will be worthless after Christmas. We'll have to throw out what we don't sell. The average demand is 100,000. I guess we call it the newsboy problem or the news person problem, but in this case, average demand is 100,000. Cost is $30 per unit. we sell it for $40 a unit, no uncertainty there, but we have to order 6 months in advance. And so we look at this and we say, well, we'll order 100,000. Yay, and then the revenue's 4 million, the cost of goods was 3 million, we make $1 million. Well, let's take a look at the flaw of averages now. I'm going to go to the SIPMath modeler tools. Now these tools are available for free. We've got the free version and the guilt-free version. For those people who've heard of Tom Keelan's metal logs, we're getting those incorporated over here on the right. But what I'm going to do then is open a library of SIPs. So I'm going to go to an external library. I'm going to browse. In here, I have a library called demand. Let's look at the library for a sec. It has some metadata. The average is at position 1001. The 95th percentile is 1002. Oh, but here's the SIP. So the SIP is just a column of Monte Carlo realizations. Who did I steal this from? Well, I stole it from the stochastic optimizers, but it turns out I could have stolen it from financial engineers or the insurance industry. I just didn't know they were doing it too. This has been around for decades. The idea of communicating uncertainties as vectors of realizations.
Now you created this with SIPMath, but this could be created with anything, right?
Right, I'm going to show an example later on what's been created. Well, it could be created with R or MATLAB or Python. Or a discrete event simulation. I'll show you an example of that. I think the important thing is we do have to mention the nomenclature. So the SIPs are basically the Arabic numerals of uncertainty. Why? Because you can perform any arithmetic on SIPs. Now, does it always make sense? No, you have to preserve the statistical relationships between the SIPs to get the stuff to really work out, right? You would call it correlation maybe. So the idea was I needed words that would tie back to something you already had in your brain, like bit and byte. So it was obvious right up front that I needed SIP and slurp, but I had no idea what those would stand for. So SIP was easy. That was stochastic information packet. And by the way, I've been told by people at dictionary.com that when you write the acronym and then try to work backwards what it means, there's actually a name that's called a backronym. Well, slurp was tortured. That's stochastic library unit with relationships preserved. And we'll get to one of those in a second. But right now, this model, this library, and there are the 1,000 trials, this library is now ready for this thing to access. So I put my cursor there in actual demand. I say, oh, and by the way, I forgot to tell you this. When I opened the library, it added this tab. That wasn't there before. That's the data table where the numbers 1 through 1,000 are going to run through this cell using the native Excel data table every time I do a keystroke. So, so I put my cursor in the actual demand cell. I go to library input. I say, give me demand. And I'll overwrite the cell. And there's a little distribution in that cell. So at this stage, I could scroll through that or that or that or that or that. Mind you, the models never require macros to run. This little thing here, I could do that by simply going over here and typing 1, 2, or 3. And in fact, if I type 1001, I will get the average demand over here. And there it is, it's back at 100,000. I have to do one more thing now to run the simulation. That's put the cursor down in this cell, go to define outputs, and then the output name is profit, and I click OK. And 1,000 trials later, there is now a range on the PM table sheet called profit. That's its name, which means that I can go over here and ask for the average profit.
So just to put this in context of a little story, what happened here is we went to the marketing folks and they estimated the demand and they put together this SIP library, right?
Right.
They put together the SIP library. We don't have it in here, but it could have gone to the operations folks or the supply group, and they could have told me what the cost of goods were. I think this looks like it's hard coded now, but they may have another SIP over here.
Right.
That's in some sort of library, maybe the same library, a different library.
Right.
Then that goes in, and now the finance people pick up their model, and all the data has been conveyed to them. They didn't have to know how it was generated at all.
And most importantly, if there's one demand, suppose you're doing production, I'm doing marketing or something, right?
Yeah, right.
And we both say, oh yeah, it's normally distributed the mean of this and the standard deviation of that. We both run our own simulations. Well, you run a simulation where demand is like 110, and I run one where it's 90. We can't add those simulations together. But at the end of the day, whatever financials come out of any of our simulations are coherent. Use the word coherent to mean they all come from the same parallel universe in the multiverse.
And so if I, as an operations person, used the demand and generated my costs associated with that, and then those two things were parallel, now I've got a slurp, what I would consider a slurp, because you have to maintain that relationship between the demand and the cost. It comes into the finance model.
That's right.
And they can do their earnings and whatever they need to do.
That's right.
Yeah.
That's right.
Okay.
So I'm now going to hit the enter key because I want to know what the average profit is. Oh no, it's 600,000. So the profit of the average is $1 million, but the average profit is 600,000. And now a question would be, why did this happen? We can also, make here, we'll make a big histogram and a cumulative up here.
Thank you, Sam.
And we'll shrink this down. Yeah, pop those in place.
Because I'm a big cumulative guy. You're a big histogram guy.
Well, the reason I'm a big histogram guy is the cumulative is great for I don't know what's happening.
What happened here, man?
You have to check with Dave. I don't know what.
No.
So the cumulative lets you read off the probabilities of various things, right? But for that, I tend to use the chance of whatever button, right? But at any rate, the thing about the histogram is it's the derivative of the cumulative. So if I do something like this, and I lower my cost to 25, well, I didn't see much difference there. But oh no, the amount I order. Let's change the amount I order.
Yeah. So see, this is where this cumulative would really help, because now I can see that I've got this vertical line here on my cumulative, and I say, why is that occur? Because I've got this boost cell that says I only ordered 100,000. I can't sell more than 100,000. Right.
Well, that also, of course, is my histogram. My histogram, which ends right here because you can't get any more than $1 million. But let's just ask a quick question among the crowd. Why is our average only 600,000? It's because we're capped at 100,000. So how many people think we should have ordered more than 100,000 so we could have taken advantage of the upside? How many people think we should have ordered less than 100,000 so we could have done the downside? Do we have any takers on that? Who says up? Who says down? Not getting a lot of takers. I will tell you that when I wrote my textbook, I figured it would be better to have more. So let's throw in 120,000 and see what the average profit is.
This is 201 now, right?
No. What we have now is 601,000 down here is our average profit.
I mean 601, excuse me.
Yeah, 601, right?
601, yeah.
So I order 120,000 and, oh no, it's 279. That's horrible.
I'm very concerned about this little negative thing over here.
Yeah.
I'm not sure about this.
So now let's order 80,000 and we make 679. So there I used a library. Now, what I'd like to do is to show how to generate the libraries. And where we really did this big time, let me stop sharing for a sec, I'm going to bring up one more model, and then I'm going to explain sort of how you would do this on your own.
Now, I guess the other thing is that these SIPs could also be sitting in the cloud, right?
Well, that's what the first one I showed. Those SIPs were in the cloud.
Those SIPs
With
were in
the
the cloud.
agriculture example,
Okay.
those things were in the cloud. And we haven't even talked about the virtual SIPs, which are going to be a tiny fraction of the size of the real, of the sort of actual SIPs, the physical SIPs. So this model was something I did at Shell years ago before the data table function even worked, but it really codified the whole notion of stochastic libraries. And so this involves picking a portfolio of exploration projects where this is the risk of the portfolio, this is the expected return of the portfolio. This is an efficient frontier with a budget of 50 million. If I do 60 million, it moves the frontier up. And so at dinner, I was showing Brian how we would do this today with SIP libraries, but I want to kind of show you the structure first. Notice in here that green dot is my risk and return. And it turns out that these two projects are subject to a political risk where they could blow up. And this one, if they do blow up, they would increase the price of gas in Europe where this project would kick in. So this project turns out to hedge those others. Look at this, I click that in, that venture 5 in, 5 out. And you can see all that happening in the slurp. So the slurp, remember the slurp can be assembled by many different people on different computers as long as they keep things coherent. So what I want you to see in the slurp here is that on trial 11, this African country blows up politically, and right down here, the ventures in that country are, are in the toilet, but this is venture 5, which is suddenly selling into a market with twice the price it had before. And so this is a SLURP, stochastic library unit with relationships preserved. All these hedging capabilities are preserved here. Now let me draw a picture on my virtual whiteboard. So we've got up here, we'll call it, let's show up, geo, econ, and politics. So we've got prices, we've got revolutions, we've got coronavirus, all that stuff. And those things are all kind of interrelated themselves, and I'm going to show you a little example of where I can build a library of those things. Now remember, on trial 4032, the price of oil is $55, and it's $55 for everybody because this model. So this is a model, and you know what? I will draw a library as like a rectangle. So this thing produces. This is the model, which I'll show you. I have one of these, and it produces a library. Of trials. Okay. And then the library can feed any number of models. So let's talk about project 1, project 2, project 3, and so on. They all read in this library. Then they can produce SIPs. These all belong to one company. You probably put all those in one library. So then they can all go into the same library. And that library, this then I'm going to call the portfolio. Library. And the portfolio library is what you were looking at right here in the shell model. So this was not the real model that Shell used. They had one that was about 10 times bigger, but this is something I used at Cambridge University in a course for Shell execs. And let me just point out that this was done before the data table, so it involved copying all the formulas down thousands of times.
So one other point here is this library that you're going to put together from the projects, it could have distribution of NPV, it could have distributions of production by year, it could have all kinds of metrics that the company might be interested in at the portfolio level.
Absolutely.
Cash flow, so forth.
Absolutely, absolutely. And at Shell, I think we went out 20 years or something.
Okay.
So we're only doing 1 year here, just to
once again, we're talking about a lot of data, so you put this up in the cloud and it's available.
Right, and then you compress it so it takes up 1,000th of the amount you thought it would take up. Now, out on our website, you'll find this article written in 2006, which kind of it was co-authored by me and a guy at Cambridge and a guy at Shell, which describes the model. Oh, is the Shell model still open? Yeah, oh no, I know. Hold on. Yeah, it describes the Shell model, which is also available online at our website. But let me start out now with a geopolitical model. So we start with this model. What's going on here? Well, I have oil price, which is pretty much the same worldwide because you put it in a tanker and you can get it anywhere for cheap. Gas, on the other hand, has to go through a pipeline, and if you don't have one, then it's worthless. In this case, we have a European gas price, a Middle East gas price, and a North American gas price. Now, when you start putting your simulations together, and remember, they do not need to be written in Excel or any particular platform, but part of the magic is this. I don't know if anyone has heard of Doug Hubbard, but Doug Hubbard has developed a cross-platform random number generator. And it has multiple seeds that you can set. So I'm thinking of this as this simulation is written by a forecasting firm, which is known as Entity 1. And if you put the number 1 in this seed, then you will never collide with anyone else's simulation anywhere in the world. This is Project 1 for Entity 1. And then on top of that, I've got individual variable IDs over here. What's going on in this model? Well, I've got normally distributed prices everywhere, except for European gas. Because here's Nigeria blowing up down here, 15% chance. Oh, just for a second, you see that if it blows up, the price of gas in Europe gets multiplied by 2. Look at this distribution sitting right up here. I'm going to change this to a 50%. And you can see that bump go up on the other side, right? But it's only 15%. So this model is sitting here and has produced all these SIPs. I save results as a library. So, I'll call it Geo. I'll put my initials in it, right? 2/4/2020. And so now this is not just some distribution that the cat dragged in, right? I dragged it in. And then I select the outputs I want, which are those, and I click OK. And there's the library. So it has 10,000 trials. It has the averages of all these things. Again, I can do that. Now, I'm not going to save this library because I already have one saved, but I'm going to show you how I use this now. So now what we're doing is we're getting down to, if we go back to our diagram, I just showed you this library. I'm now going to call up some projects and show how they make use of that library. And those, whatever SIPs those projects produce are going to be coherent because they're all using the same geopolitical library. So let's open project 1. Now, project 1 actually has already been linked in to the oil price, but let me just plug. Let me just.
Can I actually see the library that's using here?
Yeah, that's the one I just showed actually.
Okay, but I can see it in the equation.
Oh yes, you can see it in the equation. But let's do it this way. I'm going to start. I'm going to reinitialize this model. So I'm just going to type in a constant there. That's 29. I'll just whatever number was in there, and that was the only external library I was going to. Let me just reinitialize this model. So I'll start with this model as if I hadn't already hooked it up. Okay, reinitialize. Then I'm going to go to an external workbook. I browse, and I'll go to the geoeconomic SIPs. So now those have been opened up. Go back over here. And now what I'm going to do is I'm going to, let me get rid of this. That's just left over. I'll put that back in a second. But I go to this cell, oil price. So now I've opened the library. I'm attached to the library, and I say, oh yeah, I want oil price in that cell, please. Sure, overwrite it. There's the distribution of oil price. Then I need, on the PM table, it does not have an output yet. I have to specify my output. My output is going to be the profit of project 1. So I define outputs. I click on that name. I click OK. And there's the profit. So now I have that thing sitting there. Then I save results, and I will add to an existing library. I'm not going to do this because I don't want to wreck the library, but the specific library I'm going to send it to is the portfolio library, which has a bunch of other projects in it, okay. Right? So let's take a look at that library, then let's use that library. So I haven't used that library yet.
Back up there, just a question. We've been using the library here for inputs. Can we also generate, using just the generate input, another random variable within this model?
Sure, within it, absolutely. In fact, suppose in this particular model, that might be fun to do. We can call this a new project. That's probably worth doing. So all the projects belong to entity 2. Okay. We could call it Chevron. Entity 1 was, I don't know, some forecasting XYZ company. I already saved this as project 1, and I don't want to do that again. And I'm going to save it as project 2. We don't have a project 2. I'm going to save it as project 2. Okay. And I'm going to put a random production cost in here. Okay. So I thought that was my production cost, but my real production cost is normally distributed. And to do this now, I want to make sure I keep track of my variable ID. So I'm now adding a new random variable within this model. I'm just going to call that variable 1. Mm-hmm. Another model could have a variable 1 as long as it had a different project ID, because the entity, the project ID, these are all moving us to different hyperplanes in this HDR random number generator. So I'll say over here that the actual cost, I'll just, to make it fast, I'll just put a normal distribution in here. And I'm going to use, first of all, I'm going to use that variable ID over there as my starting variable ID. And my mean is going to be 27, and my standard deviation is going to be 4. And I click OK. And first of all, if I brought this back to number 1 here, then this model would end up being correlated with
Mhm.
with project one, but I'm going to two, and now I've got this other variable here. If I look at the trials and I scroll through, well, we see the prices changing. We see our production costs changing. Remember, the prices are changing from that other library, from the geopolitical library. Now, though, let's see. Have I?
Do I want a special random number here such that this production cost is associated with project two?
No, you don't. You don't, because it says project two locks all the project two, makes all the project two random seeds on their own hyperplane.
Okay.
We don't have to worry about it. That's the beauty.
You don't need to specify that.
That's just the beauty of having those things. Now, I want to get rid of this output cell because it's still called project one. So I'm going to go up here and call this project two profit, and we're going to end up adding that. Oops, project two. We're going to end up adding that to our library. So click on that, define it as an output. That's the project name. There's a little distribution. And then that's my output. Now, of course, it's correlated to project one because they're both using the same world oil price, but they're not perfectly correlated because this one has a random production cost as well. So now let's go save results to an existing library. The existing library is the portfolio library. Select the outputs, project two profit, click OK. There's the library, and then I'll resave it. Now look, here's the order. I have project one, project four, project three, project five, and project two, because that's the order in which I saved them. I'm going to save that library. And now we're going to start looking at portfolios of those projects.
Okay.
So now we get to the portfolio fund. Again, I think these are 10,000. Very good. Let me close everything I have here. Typically, these models don't interfere with each other. Remember, I was talking about the HDR random generator, which is seedable. You can also use the RAND function, but that is something that the cat dragged in. And not only that, it'll work in a single model, but if you tie multiple models together with RAND functions in them, they interfere with each other. Okay, new model. This is a model of my portfolio. And so I'm going to look at an external workbook. I'm going to browse. I want my portfolio library. And by the way, we're working without a net here. This is the first time I've ever tried this library. Fine. Now, how many I got 5 projects. So I'll put them across 1, 2, 3, 4, 5.
Could I go look at the number of things in my library now without doing this?
Yes, you can. You can just Alt Tab, and there they are. 10. So it's got 50,000 things in there. If an accountant starts hassling you, I want you to go talk to them about that.
Okay.
Okay.
Okay. And I see the 5 things in there.
And so now I'm here. 1, 2, 3, 4, 5. Library input. Put these in as a row. And I am going to ask for I'm going to ask for all these projects. I'm going to ask for their names. And I'm going to put the names up here. And then I'll click OK. I can decide where I want the sparkline graphs to go. And maybe I'll put those down here. Sometimes I like to have them in the cell, just so you know the cell.
Now, it's interesting you selected 2 rows there, too.
Yeah, so I got a big fat sparkline.
Yeah.
Right. Now, let's talk portfolios. So, 1 is in, 0 is out. The portfolio down here is simply the sum product of the various NPVs of the projects with the vectors of zeros and ones, and I will call that portfolio and make that an output, define that as an output, and oh, make a nice big spark line over there. Okay, now of course, when I put in ones and zeros, it does a 10,000 trial simulation. And what I might be interested in, oh, well, we'll take a look at a couple of these. But of course, I'm interested in the chance that this is over greater than 100. So I just say greater than 100. I didn't show you what the chance of whatever formula is. So the chance that that bears this relationship to that is a count if formula. Just very simple. Remember, everything we're building is native Excel. The macros help you build the model, but then you can ship it off. So I can change these. Okay. But, right, we're not quite hooked up yet to do the XY charts. Darn it. Oh, wait, I know what I can do. Let me use these as output cells for a minute. So I'm going to call these Proj 1 through Proj 5. Obviously, they're in different order from the original, but it doesn't matter. I'm going to select all these. These are now not only input cells, I'm going to make them output cells. And the reason I'm doing this is that then I can do scatter plots of one thing versus another. Now, we've got 10,000 trials. I don't know how well it'll work, but let's try it out. Go to scatter plot, and let's look at the X output as project 4. Let's see. Yeah, we'll do project 4, and the Y output as project. Yes, I don't want to pick the name there. I want to make this the actual output cell, because these are two projects that theoretically should hedge each other, right? Well, something's happening. So we can see now, let's try some other projects. Remember, this model actually uses really simplistic, like decision tree, event tree. You had high output or low output. And so at any rate, for any two of these, we can do scatter plots.
Yeah, but now what my suggestion would be to just have numbers up here, 1 to 5, and then pick those two numbers, then always plot that. You could just change.
Yeah, that'd be a nice way to do that.
Yeah,
exactly.
yeah.
Or just pull down their names from something.
Sure.
So 8:30.
Yeah.
Good. Well, let's stop anyway and let everyone catch their breath. Any questions out there?
So the other thing I might add here is, let you be interested in, how you think you might be able to use this in some of your companies. So Tom, you're involved in water evaluation, water treatment, that sort of thing.
And water system simulation. So we actually use the probability management tools in constructing spreadsheet-based simulations that can visually communicate uncertainty.
Are you using the libraries like Sam's been describing here? Or?
Yes.
You do? Okay. So there's a practical application for you, Sam.
Right. Here's another application as well. If you have extremely rare events, you can use sparse libraries. And that's some stuff that I've developed actually that has a patent pending on it. But you can do ridiculously rare events and 100 million trials as long as you don't store the trials where nothing happened.
Right.
But I don't recommend anyone start down that path right away. here's an example. Let me give you an example of where a library could help us in modeling the effects of climate change. So yeah, I've got two more examples I really want to cover here. So one of them is, let's model the economic impact of sea level rise. And I don't talk about it that much, but really the whole rationale for probability management is this. The general public just can't use simulation because they don't know how to generate the required distributions of random numbers. I think everyone in this group would have to agree to that. But does this mean they can't use light bulbs because they don't know how to generate the electricity? Of course not. We developed a power grid where the experts generate the electricity. They use the 60-cycle AC current standard to deliver it to the rest of us. Well, now I can tell you what probabilitymanagement.org has done. It's developed the 60-cycle AC current standard for probability distributions, but not like saying, well, but I could have told you it was a normal with a mean of this and a standard deviation of that. No, you couldn't, because then if I gave that same distribution to someone else, you wouldn't get the same trial, the same value on the same trial, and you couldn't add them together. You couldn't do arithmetic with them. So very quickly, these things are actionable, additive, auditable, and agnostic. And I want to go to the additive. Let's abandon this. That's just, the analogy is, don't tell me it's a normal distribution. Tell me the socket in the wall where I can plug my simulation. But here's the bit about additivity. So there are big global climate change models. And what if we wanted to add to that global climate change model the economic impact of, say, 500,000 coastal regions? Well, that's fine. Each coastal region has like a little table of sea level height and damage. And so we send those 500,000 tables up to the global climate. No, we don't. Come on, you can't. This model is collapsing under its own weight already. You couldn't possibly add 500,000 more elements to it. But if you publish those clouds, those SIPs in the cloud, the SIPs of uncertain sea level rise, then each of the 500,000 models sits here and reads them in with, for example, local knowledge. Could there be any local knowledge? You think, like, you know, what's the hydrology of the bay and that kind of stuff? Now, here's a very important thing to observe. You see that all the flood heights are going up and down together because there is only one sea level rise. It's a global variable. These things are kept coherent. And then the SIPs from these models, again, they include the local knowledge and local uncertainties. Those things get uploaded here to the star of our show, the summation sign, and here's the distribution of global impact. Oh, here's another great one. One other great model I had forgotten about. So I have found SIPs out, actually, the SIP generator is out in the cloud at the Federal Reserve Bank. And they have an economic model called PRISM. And in fact, where this would really make sense is in banking regulation. This model is using SIPs that were generated from a MATLAB model called PRISM that is out. I can send you the URL for it. Again, I don't want to open Chrome right now, but let me show you some of the things that came through here. So they have this big econometric model. Here's GDP, 13 quarters times 1,000 trials. Here's consumer price index. And then there's the Fed rate. Well, I go back to the dashboard and you show this to an econometrician, you know, and they say, I've seen that before. Everyone's got these 5th and 95th percentiles in the average. I said, no, no, no. No, there are 1,000 moving parts. There are 39,000 actually, 1,000 times 13 time periods. One of the things you'll notice right away is that this is their model, not ours, but the MATLAB was open source and we just ran the thing and sucked the slurp out of it.
Yeah.
And so you'll notice that GDP by quarter and inflation rate by quarter are quite smooth. You'll notice that this rate is very bumpy. Why is that? Well, I'll tell you what, and I surmised this looking at it, and then I confirmed it with the Fed.
Excuse me, what was the R for?
Good. What is the R for? The R is the Fed with their hand on the steering wheel trying to control things based on what these are doing.
So this is their bank intercompany rate or something of that nature?
That's just like the Fed rate. It's like the Fed rate. So what we're seeing here is these two are the direction of the car. The first two are the car going down the highway, and this is the movement of the hands on the steering wheel. But here's the beauty. Imagine these SIPs in the cloud somewhere. Then we have multiple institutions that have got risk models. Here I've got these lagged regression models, lagged on these factors. But you could have any number of institutions. And suppose this is their balances. Well, what do we have here? Institution 1, I'm going to change that regression coefficient from -0.1 to 0.1. And okay, it changed. Here, undo. Every keystroke is 39,000 moving parts. Oh, but what's this? A plus sign? By golly. So these do not need to be in one model. The SIPs of each of these banks could be sent to the Fed, and they could then put together all the SIPs, just add them up to see what the health of the economy was. I want to point to one other element, one other area that we're working in that's quite exciting.
Ask one more question here. So the Fed could use this to decide on a decision policy around, they could say, well, what I'm going to do this quarter is a function of what's happened in the last 3 quarters.
That's right. And they were doing that internally already.
Okay.
What I'm saying is whatever model that drives of GDP and inflation. Look, currently in banking regulation, they give banks like 3 or 4 scenarios. All I'm saying is it should be 3,000 or 4,000 scenarios. We can do it. And more care should be taken. The scenarios are a little fluffy. And I got to say, the banking regulation business, they sure didn't catch 2008. I think they're sort of covering their own tails in terms of we don't want to show too much risk here. And one of the articles I read, and I think it was in the Wall Street Journal or New York Times, was in 2008, the banks were all looking at what was going on. And they said, well, we don't have to worry because we have a risk management department. Right, famous last words. Now I want to show one other thing here. I'm going to stop sharing here. So an interesting area that we have just started opening up is military readiness. We're doing things in just all kinds of areas right now, but we've had 3 publications. So we've had 3 publications in the last, well, since September on military readiness. And I'm working with someone in the Pentagon, a guy who's fresh out of the Marines. And so in Phalanx magazine, which is the military operations research magazine, in ORMS Today, and another one in Phalanx. And so military readiness is another place where the bar is set very low these days. And what you find, well, I think I should describe the granddaddy of them all, the granddaddy of the poster children of bad readiness. So it was 1980. We had American hostages in the embassy in Tehran, and they sent off a rescue mission called Eagle Claw. Well, they knew they needed 6 helicopters to pull off the mission. And they knew that helicopters are not 100% reliable. So someone said, well, what is the MC rate for helicopters? That means mission capable, which means if you had thousands of helicopters, what percentage of them on average would be ready to fly? And that's 75%. So they said, we'll send 8 because 75% of 8 is 6. They didn't say, what's the chance of having 6 if we send 8, which coincidentally is 68%. I don't know if there's a connection there or not, but if you'd ever heard of the binomial distribution and heard of this plan, you'd have said, you're sure you want to settle for a 68% chance of accomplishing the most important military mission since World War II? And they probably would have said, no, maybe we should send another helicopter. Carter said that when he was asked if he had any regrets about his presidency. He said, yes, we should have sent another helicopter. So that's where the bar is set. And so I want to show you a very cute model that we've built of military readiness. This is also on our website. So this is what's known as an air wing. An air wing is the complement of aircraft on an aircraft carrier. And one of our articles is called From Ready or Not to How Ready for What? Because seriously, I've got 10 fighter squadrons. A squadron is considered ready for action if it's got 8 fighters. So suppose you have 10 fighter squadrons and they each have 7 fighters. And you get to use them all. Well, the way they do it now, they say, oh, none of the squadrons are ready. We're dead. It's like you could add 2 squadrons together, couldn't you? But then they wouldn't know how to do that. They'd say, well, what is that? 70% plus 70% is 140% ready? That's not right. Is it not ready plus not ready equals? Anyway, no, add SIPs together. So here's the SIP library. And here we have these different airplanes. Here's the library. This is a slurp. Now it was built up, it was rolled up from single fighters. And I'm going to show you now in a minute, a discrete event simulation for simulating, a squadron of fighters. But you could do it fighter by fighter, but there's some global variables. For example, on trial 15, the oxygen system went out in F-18s. They had to ground them all. The Growler the radar jamming plane is also based on the F-18, and so it's taken out of the mix. But now we go over to the dashboard and we say, remember, in the arithmetic of uncertainty, what do you want it to be? Here are the chances. Well, I want 30 strike fighters, 3 Growlers, 3 Hawkeyes, blah, 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 blah. And the arithmetic of uncertainty says you got a 61% chance of being ready. What does that really mean? There's an expression in the military, when the balloon goes up, left over from World War I. Have you ever heard that phrase?
Oh yeah, absolutely.
I had not heard of that. It meant the enemy's observation balloon just went up. That means the battle is starting, right? So we don't know when we're going to execute this mission, but we know what the mission is. And so we have a 61% chance of being ready. Not only that, but we know that there's a 43% chance the strike fighters were the ones that caused the problem. So I said, well, what if I could live with 28 strike fighters? And 10,000 trials later, that goes up to 69%. And now I discovered that the real shortage is on helicopters. Well, what if I go down to 10 helicopters? 78%. I'm getting there. I'm getting there. Oh, the Growlers. Could we get by with 2 Growlers? Oh, well, now we're at 83%. Maybe we're comfortable with this. The commanders don't really have this tool currently or anything like it. Now, Phil Farringer, one of our supporters at Probability Management and my main contact at Lockheed Martin, has created this Markov chain Monte Carlo simulation. And let me see if I can bring that up.
Yeah, about 10 minutes or less.
Very good. Okay, so here comes the mission Markov chain Monte Carlo mission capability, or MC cubed. And I'm going to, there's no audio on this. I'm just going to play it through.
Maybe you could describe it as it's playing.
Yeah, so this is, and I can stop it in places too. So look at the airplanes moving around now. So you have a Markov chain that represents the various states that an airplane can be in. This is an F-35, and we have a squadron of 24 of them. So look, here's the F-35. Well, there's a chance it'll have a flat tire. We got to fix the flat tire. Got to empty the ashtray. I don't know what you do on these F-35s, but different stuff. And so now we see this thing moving around. We're simulating the various planes. And then we end up with, we run it to steady state. And now we get a distribution of the number of planes available. What kind of distribution? Don't ask, don't tell. It is what it is. It came out of the simulation, but we can generate a SIP out of that. And that SIP is then used to drive the other Monte Carlos. And this becomes basically, you know, a Lego block in a readiness roll-up, which just does not exist today. And we're hoping, again, because the bar has been set so low, a couple of colleagues and I have presented this a few places, and we've been invited now to present a paper to something called the Military Operations Research Barchi Prize. And so we're writing that up now. But it gives you an idea of how you could have SIPs being transported across platforms. And of course, the one with the Federal Reserve was the same kind of deal. Okay, I'm going to stop sharing.
Okay.
Maybe there are more questions. I'm going to bring up that Federal Reserve site over here, and then we can maybe take a little discussion.
Sure.
About that. But the thing you want to look up is the Philadelphia, or I'll say Philly Fed PRISM model. PRISM, Philadelphia Fed. And you'll notice, I know it's kind of small here, but wait. What they post, let's blow this up. What they post is just the mean and the confidence intervals, and that is not actionable. You can't add 95th percentiles together to get the 95th percentile of the sum. But if you add the SIPs together and take the 95th percentile of the sum, you got the 95th percentile.
The positive comment I'll say about this is they've shown some historical data here along with the confidence intervals. So sometimes, you know, you present to management and you just show them the confidence intervals going forward, and there's no perspective of the history. So I like the fact that they've got a history here.
But bear in mind, they publish their MATLAB model.
Mm-hmm.
So they give you the whole thing. I mean, I think this is beautiful transparency on their part.
Yeah.
Okay, I do have to show one other thing. How many people have seen metalogs? The metalog is the invention of Tom Keelan. It is the Taylor's series of probability distributions. It is remarkable. And I do have like a 1-minute version of that presentation because we are intending. Let me show you one more thing. Just take a minute. This is quite an amazing.
So it's a metalog. There is a metalog function in the free version of SIPMath, but then there's a more advanced version that's in the guilt-free version. Guilt-free,
yeah. So this is sort of remarkable. This is using metalog distributions to model the duration of tasks. And we see this Gantt chart here. I'm going to change these like this, right? So every one of these is another trial. Another trial. And this is conditional formatting that gives you the Gantt chart based on random numbers generated here. And here's the thing that's going to knock your socks off. There's nothing down here. This is just empty space down below me, okay? The world does not exist down there. Do that, copy that.
You're not over an A.
Oh, didn't get over far enough. Ooh. Yeah, okay, there, I got that. Right, now how about if I just go there? There it is. Oh, you want another one? So what we're doing is we're sending airplanes in to get their wings rebuilt, and we just keep sending, and now, shrink it down, it is utterly modular. I can just keep copying those things down until the cows come home, and it keeps getting pushed further and further out because there's one thing in a delay process. This red line is where the planes are waiting there with their wings taken off, and I haven't been able to get the new wings on, okay? So I just thought as a last example, I would show that, and then, yeah,
So what you might show here is you go to SIPMath Modeler Tools and go to Generate Input. You can see that Metalog is one of those that you can identify. And then over on the right-hand side of the SIPMath Modeler Tools, you've got this more elaborate Metalog thing, where I believe what you could actually do is you give it data and it will fit the Metalog distribution.
Yes, and that, we've got 4 minutes left. If you're interested, the Metalog is just an amazing thing. I would say it's like a cherry picker. Suddenly there's all kinds of low-hanging fruit you hadn't thought about before. Once you can start really specifying probability distributions like Taylor series. Those who have seen it, I think will back me up on that. It's been very exciting to work with Tom on this stuff.
Okay, I think it's time to wrap it up here, Sam.
Okay, good.
So I'm going to go share.
Yeah.
And I just really want to make sure that anyone who's got a question here for Sam gets it asked. And I hope I didn't. Maybe I missed. I hope I didn't miss any chat things. I haven't been real diligent in looking at that. But you can send me an email if you have any questions of Sam or about SIPMath. You can send them to me, or you can find Sam's email address probably in Probability Management's website, and we'll get those answers. So the other thing I wanted to say is that we're always looking for presentations and to talk to me about ones that you like to do. I've got a couple more for the next couple of months. It may not happen in March. I've got a lot of travel plans, but we'll get a couple more meetings going here. So I want to thank all those that have been participating. I think the ones back in Florida, it's getting pretty late back there. It's 11:30, okay? And then we got Calgary and other places. So thank you all. Any other comments from anyone here?
Say again?
This was good.
Okay, thanks, Mike.
I do encourage you to visit probabilitymanagement.org. You can get the free version of the tools. They're quite amazing. There are tons of models out there. And again, this is all because of the miracle that Microsoft fixed the data table at one point. And it might have been as early as, I don't think it could have been much earlier than 2010, because 2007, when they went to 1 million rows, that used to blow up right and left anyway.
And you're talking about the versions of Microsoft.
Yeah, 2000.
So the other place to find some examples is my YouTube channel.
Oh, yeah.
I've got 80 plus videos out there. Some of them just talk about techniques with SIPMath, and others are actually the full models to include some cost and schedule risk analysis and value of information and portfolio. They're a little bit different. They don't use libraries, but they probably could be improved with libraries, Sam. But
well, we'll have those videos up sooner or later. Hey,
Sam, thank you very much.
Thanks for the invitation.
And thank you, everybody, for participating. We'll sign off here.